This is it. Last one. Doesn't have to be. We can do more too.
Okay, if I don't do well on this one.
Yeah. All right, ready? Today, we are vibe coding GPU kernels in CUDA. My name is Waleed. I'm the founder and CEO of Mako, and we make software that automatically unlocks peak GPU performance. To do this, we've been working on an AI agent that can generate and validate high-performance GPU kernels in CUDA, Triton, and any other language. To this end, we are very, very excited to announce and release the MakoGenerate platform. It's an agentic playground where you can mess with different models, use your own prompts, and configure an agent to automatically generate and validate GPU kernels. You know, we've been working on this for a while. I'm joined by Mohammed Abdel Fattah, our Chief Science Officer. I've got Mahith, I've got George. They've been working on the kernel generator a lot. Mahith, why don't you walk us through how this works?
Yeah, hi, my name is Mahith, and we're the team behind the MakoGenerate platform. We're super excited to show you what we have. As Waleed mentioned, this is an early research demo. And so it does a lot of incredible things, and it also does some silly things. But enough of that, let's get into the demo. This is the product we have. We have a superset of Stanford's kernel bench problems. This includes a bunch of super interesting PyTorch reference code. We start off with pretty simple operations like standard matrix multiplication and square matrix multiplication. But as we keep going, we'll get some more interesting problems which are a little bit more difficult. And if we go all the way to the end, we'll get some very interesting things like Llama 2. And you know what, let's do RWKV as a demo.
Yeah, good real world example.
Yeah, and the cool part of our platform is that you can actually configure your own agent. And so this includes doing things like selecting a model, selecting the backend, selecting hardware, and like even selecting how much compute you want to throw at it. So you really have full freedom on how to configure it. Let's choose OpenAI's O3 model. And you know, let's set compute to 6 kernels. And let's throw a prompt at it. And I want to make sure that we're minimizing global memory access, so I'm going to prompt that into it. And let's run the agent.
All right, so the agent is off. It's working on it. I see the generation thing twirling. George, what's really going on in the background here?
Yeah, thanks for asking. So when you press the generation button, what happens is that the reference code is going to be sent to the master planner that analyzes and comes up with a strategy. This strategy is going to be implemented in an iterative fashion, and then it's going to actually generate a functional kernel. Over here, you can see generation, compilation, validation, and benchmarking. So after generation is complete, it's going to go through some evaluation pipeline, which goes through compilation, validation, and if it's correct, it's going to go through the benchmarking.
Right, and this iterative pipeline is really cool. It runs on actual GPUs, so we know that compilation works. We know that the compiled stuff actually runs on it, and then it iteratively improves and fixes errors if there are any. Iterative refinement is cool, but it's not the end of the road for us. Mohammed, what else do we have coming?
Yeah, we have a bunch of features that we're trying out. For example, we perform agentic search to sift through GPU documentation and use the latest, GPU hardware features. We also give, in-context examples of code generation to form a few-shot prompt, and that really improves, the final generated kernel as well. And more importantly, we perform evolutionary search. So we don't just generate one kernel and iteratively refine it. We generate a number of kernels in parallel, and we apply different optimizations to each one, and we evolve further the ones that perform the best. And last but not least, we're actually training our own model as well. This is coming soon, but we're kind of really leaning into reinforcement learning to customize models and over-optimize general LLMs really for GPU code generation.
All right. And last but not least, the cherry on top, we're not just generating GPU kernels. We have the entire software pipeline that can automatically integrate these kernels into PyTorch and into popular inference engines like SGLang and VLLM. See us on mako.dev. It is free. It is in research preview. It is available right now. It's something that you can go to actually use today. And let's check out the final results of the kernel that was generated. And take a look at that. So it actually did successfully generate the RWKV kernel, and now it's off on its second attempt. It's going to keep refining, and you throw some more compute at this, you can expect the results to keep getting better and better. All right. Thank you very much. I appreciate the time. Make sure to check it out and let us know what you think.